Today we are gonna make some automated circuit for the bathroom exhaust fan. Lately we have seen that the bathroom fan, I made some modification. It was noisy, and now there is absolutely no noise in the bathroom fan. So even you pass by the bathroom door, you still don't hear the fan, and it's very strong flow of air. And I have seen the electrical bill, especially in the winters, have gone up. It just keeps drawing. Sometimes it's on for many hours and we forget to turn it off. So I'm just installing this upstairs two washrooms, and so I have two washrooms, one big one, the family washroom, and another is smaller one. Both of them have bathtubs, and the big one has a shower room as well, where all of us take shower. So I have made two versions here. So this one is for the smaller washroom. This is gonna turn on for around 7 minutes on the low supply, on the low power, and it's gonna turn on about 13 minutes for the higher range. On the other washroom I have made this version. So this is around 12 to 13 minutes on the low settings, and on the high settings it runs around 22 minutes. So I will explain the basic construction in here. So this is a small power supply. This is a switching mode power supply. I took it out from the LED pot lights. So they always have a small power supply there. Don't throw those away. They are very useful, very tiny, but they get your job done. They are generally rated for around 4 to 6 watts, but here we are just using maybe 40 milliamps, so very light, so they don't get loaded and they don't get hot at all. So basic principle is that we supply the AC here, and then we take out the DC, then we regulate these. This is just to remove ripples, the small ripples, and this one is also the big capacitor which smooths out the ripples, and this one is to take out the noise. And this is the capacitor which governs the length of the timer, and I'm using 555 timer here. So I will draw the circuit. Is very simple, and pin number 3 gives you output, and this is generating around 14 volts of DC, and I have a relay which is 9 volts. So I put in series 220 ohm resistor to give me exactly 9 volts into this relay, and this is rated for 250 volts, 3 amps, and I'm just driving a fan which is probably 250 milliamps of the current, or maybe half an amp of the current in those cases, but it doesn't matter, it can handle 3 amps. And then this capacitor is a heavier capacitor as compared to this one. This is 220 microfarad, this is 470 microfarad, and I have used resistors in series to bring up I'm sorry, I have something in my throat. So to bring up the timing for the circuit here. So I have 680K and 1 million, and this is 680, 1 million and 1 million. So this is 2.6 million ohms of the resistance, and this is 1.68 million ohms resistance. So 1.68 million ohms gives me around 12 minutes, and 2.68 million ohms gives me around 22 minutes. Here I have 220 microfarad. So I have two setups here. One is this kind of dodgy, but it's DIY, so you see on the back you don't get anything. So once you start making it, just finish it, otherwise you will be lost. So this one, one side is 1.68 million ohms, and other side is 3 million ohms. That goes, so you can switch between these two. So this is low setting on this side, right, high setting. Similar two designs here basically. So I have put 555 right on the board, and this is Jumbo Bumbo underneath. So I'm gonna tell you how to make the connections. And this one I have used a seat for a 8-pin seat like this, and then I put the IC on top of it. Alright, so let's draw the chip here. So this is the chip. So this is pin number 1, 2, 3, 4. 1, 2, 3, 4. This is number 8. This is number 5. This is number 6. This is number 7. So put it inside. 6, 7, 8. So pin number 1, I will be using the dots to show that there is a connection here. So this goes to earth. Pin number 2 is the push button. Pin number 3 is the out, which goes through a resistor which is 220 ohms, and then it goes to the relay. You can find any number of relays, but generally they are I have the relay which is 6 pin. So these are the things. So this is the relay that you put in there. So basically this goes like this, okay, and you take out the mains from here, and the input for the mains goes there. So this goes in main, and this is out. Okay, we'll go to that one, but let's discuss this one. Between number 5 and ground there is a capacitor here. This is C, and you can use 104, which is 10 nanofarad. Number 6 and 7 are connected. And this is connected with a capacitor, okay, and this goes to earth again. This is in two versions. Let's take it for 70 microfarad. Number 8 is connected to VCC. This is the main power that comes out of here. So this is in this case this is around 13 volts, and then it is connected to number 4. As you have seen that this capacitor is governed by the two sets of resistors. So you connect pins 6 and 7 to the resistors. I have taken two set of resistors. One is 1.68 million ohms and other one is 2.68 million ohms. So that will govern the lower the resistance, less is the time, higher the resistance, higher is the time. You flip the switch, so either it will be connected to this side or it will be connected to this side. That will determine your timing. Very simple. This circuit is basically complete. However, you need to put in this push button in here. Okay. For that one, we have to be really careful here. Why we have to be careful? Because even if you bring a small wire around pin number 2, it's gonna switch on the circuit here, and you don't want to do that. You have to have a control that when you really push it, then only. It's just because of some noises inside these power supplies. They are not really smooth. They are just built for LEDs, so they have a lot of noise. Even if you put noising filters, but still you have those noise, and that can generate, this internal circuit can also create some noise. So what you do here, you have to put a capacitor. So this one here is a resistor which is 10K. This is pull-up resistor, and then you put a capacitor here, a ceramic capacitor 104 number, which is 10 nanofarad, and this one is connected to earth. This capacitor that I have here, I will describe the capacitors that we have. So 104, which is 100 nanofarad, and 104 again, this is 100 nanofarad. So that is a correction here. This is how you build it. Okay, come to relay. So from relay, one end will go to earth, this point, and this point. So let's make it more sensible. So this is the relay. So this relay goes here, and then it connects here with pin number 3 with a 2 ohm 220 ohm resistor. So it drops 13 volt. It varies. When there is no load or less load, then it is around 15 volts, and when there is a little bit of load, this circuit load, and this when the relay engages, then it drops to around 13.56. So with 220 ohm, if you don't put this resistor, there is a danger this relay is gonna burn. This is the relay I have is 9 volt, but I will suggest that you take 12 volt relay. 12 volt relay can very easily run 15 volts easily, and it's always better to protect this relay. And one more thing that you have to do about this relay to avoid the flyback current. So from negative side to the positive side, you put a diode. So when relay switches off, it generates the reverse current. So to avoid the reverse current, you put a diode from minus to plus side. So I have put an SMD. This is an SMD diode here. So this is negative, this is negative, and this is positive. I'm gonna put these 3 wires onto this one, and then I will be done. For this switch, you remove this switch and drill the holes here. So this is 12 mm. I have a large push switch, and then another one you drill it here. So let's do that. This is for the switch high and low, and this is for the push button. So in the end this comes to like this. So you push the button and this is high side and the low side, something like this. And this portion is gonna be shrink wrapped. I made this and then shrink wrap it just in a sleeve, so that the board is protected from any contact with any wires, and as well as if something goes wrong in the traces here, then shrink wrap is gonna protect, because shrink wrap is not gonna catch the fire. So this is the final preparation. This is how it looks after the installation. So I just put 2 marks here, one there and 2 here. 2 represents higher and this is lower. And then I just removed the switch and put in this one. This is the exactly same size. And here you have to be careful about selecting the neutral and the hot wire, as I said before, otherwise it will not work. I have done in all 3 washrooms and timed in different minutes. So this is one of the washroom which just has a tub which is not that much used, so it's 7 minutes on the lower side, higher minutes is 13. This washroom has the central main exhaust fan, which can also be controlled from downstairs. So that's why the timing here is less, because this pulls out a lot of air. Sometimes if you need to vent out the house, you can switch it on from downstairs. You don't have to come upstairs. This is the main washroom, and this one is on the low side. This is 12 minutes, and on the higher side this one is 22 minutes. And this fan here, the exhaust fan, is not really so strong, so I needed more time to clear out the moisture. This one is the powder room downstairs, so it does not have any shower bath facility, so it's just air out. So I put this here only for 5 minutes. That is enough to clear up the air inside.